Hello everybody and welcome to Double G Studios. Before I begin, let me give a shout out to Arlo. Happy birthday, Arlo. You're going to be 8 this Saturday. See you then. Okay, so still got the wrist brace on. Getting better, but not much. It's healing extremely slowly. I'm very impatient about it. However, it is what it is, so can't play guitar. So instead, I've been concentrating on my astrophotography. And fortunately, the last couple of weeks, we've had a lot of clear skies and a lot of moonless nights up until recently. So I've got a lot of observations done, and during the course of doing those observations, I've learned some new skills on how to process all of my images, and I'm going to talk about that today. So one of the things that I've learned over the last couple of weeks is that it's good to cull your FITS images before you process them. So in astrophotography, the images you take are referred to as FITS files. FIT is the file extension. Basically, it's a picture, just like any other digital picture, but it's referred to as a FITS file. It's a raw format photo file. It's very large in size, depending on the size of the sensor. And so every picture you take in astrophotography will generate a raw photo file, usually with the extender FIT or FIT. And when you do observations, you will take hundreds of these pictures for each observation. Now, in my case, maybe not hundreds. There are some observations I do that are as short as maybe 10 or 20 pictures. But the main idea of astrophotography is to take a lot of pictures of an object as you track it across the sky, and then stack all those pictures and process them into one master photo. So the other thing about astrophotography is the longer you observe and the bigger the stack you make, the better your pictures will get. One of the things about creating a stack of pictures, though, is that you will have a lot of bad frames or bad pictures. Now, in astrophotography, they call their pictures frames, so you're going to hear me refer to frames. When I'm talking about frames, I'm talking about digital pictures. But once you create a stack of frames during an observation, you're going to have some bad frames. There are going to be frames where satellites track through the picture. There'll be frames where the stars are a little bit out of focus because the telescope is in the process of realigning itself. There's a myriad of reasons why you may have some bad frames. Maybe a cloud drifted through while you were doing your observation. So stacking software will generally weed out a lot of those bad frames, but it will not get all of them, which is something that I've learned recently and I have confirmed through my own research. So it's a good idea before you do process your files with stacking software to go through them and cull out all the bad ones that you can up front. That will just make your data better, will make your images better. Once I learned about that, I started looking around to see what tools were available that would make it a bit easier for me to cull files. And the software that I was suggested by my computer AI, my Copilot. The software my Copilot suggested was ASTAP, and that is the software I am using to analyze my astrophotography frames and help me cull out all the bad ones. So I'm going to talk about that a little bit today and show how I use that to cull my frames. But in addition to that, though, I'm also going to talk about the database I created to track all of my astrophotography observations and frames. You see, it did occur to me while I was using the software to cull my frames that I might have a way of assembling a database to deal with the enormous number of frames that you generate when you do astrophotography. So toward that end, I dusted off my old Excel skills from back when I was a working person and pulled up Excel that I hadn't touched since 2022 and went to work assembling a FITS database, which I will demonstrate and show to you today. First, let's talk about the ASTAP software that's used to help cull your images. I'm going to go to my desktop and show you what that software does, how it works. Okay, so when you turn it on, it doesn't look like much because it's a bare bones piece of software. It does what it needs to do without being real fancy about it. The big black area that you see here is a viewing area. It's an area that we're going to use to view frames. This is one of the last things you will do when you cull your frames, is you will visually check every single one of them. No matter how good software is at culling your frames for you, the human eye is the final check on whether you keep a frame or not. But there are a lot of software tools that will help you cull your frames down to the point where you can then visually observe them. So this is what the software looks like when you fire it up, and you have a very few things to choose from here, but there's a button here called Stack, which does the exact same thing as this button with the Greek letter on it does. Pressing this button will call up the stacking menu, because this is stacking software, although I'm not going to use it for that. I use Cyril to stack my images. However, I will use this software to cull and get rid of bad frames before I take them to Cyril. So this is the last batch of FITS that I processed. I'm going to go get a new one. So last night I was able to get some observing done, even though there was a half moon out, which ruined the night sky. Nonetheless, I did some observations anyway because I don't care. Why not? One of the things you can do when the moon's out is you can get a lot of star clusters. So I went after a bunch of those. So anyway, let's just look at all the observations I made last night. I observed IC 447, and I did a Jupiter stack that I'm going to process later. That should be interesting. M46, M47, M48, those are three of the Messier objects I've never had before that I was able to get last night, and a few other objects. So anyway, I have already logged and culled frames up to M48, and I'm ready to start working on M48. When a C-star telescope generates files, it generates them for each observation in two folders. So in this case, I have a folder called M48 and a folder called M48 sub. The folder M48 sub is where my light frames are located. Folder M48 simply just contains the output files that the telescope provides when it does its own internal live stacking, which I will not be using those files. I will make my own. But anyway, the light frames will be found in this folder. I've already organized them into a folder called Lights. So let's open that folder, and here are all the light frames that I got on this particular object, M48. All you need to do is just highlight one of them and then press Control A on your keyboard to highlight all of them and open them all. So I now have every light frame for M48 that I shot last night loaded into this software. So the first thing I will do is click the Analyze and Organize Images button. And we'll do that, and you can see what happens. So the software has gone through and given the each one of these images an initial analyzation. It's assigned each image a HFD number, which is a number that helps determine the quality of the focus, and telescope alignment, I think, is also considered in that number. No expert here, but I think those two items are used to help comprise what this number is. Generally, a lower number is preferable to a higher number. Get a quality rating. So again, in this case, the high numbers are better than low numbers. You get a background rating, where in this case the low numbers are better than the high numbers. And you also get the number of stars detected in the image. And low number stars versus a high number stars indicates you probably had some clouds going through. There's also a column for checking on, I think it's called streaks, and we'll get to that in a minute. But anyway, so the initial run through, I will filter by quality to see if there's any quality problems. And if there were, they would be highlighted with a thumbs down, and in this case they are not. They didn't detect any huge quality problems. I can see that the HFD range is running between 4.6 and 5.3, which is not too bad. The background is running between 548 and 746. That's a bit of a range. There might be a few frames with some clouds in them here, is what that kind of tells me. And number of stars. So it looks like on the low end 187 and on the high end 270. It's not a terrible range. So these frames might not be bad. But anyway, next thing I'm going to do is hit the streaks button and let the software determine if there are any frames that have satellite streaks through them. And if it finds them, it'll highlight them, and it did not find any. So at this point now, I will click this button up here to organize the files in the order in which they were taken. And at this point, these are all the light files I'm going to keep. I didn't really have any to cull unless I find some bad ones in the visual inspection, which I'm going to do right now. So to do a visual inspection, I'll double click on one of these files. I'm going to move this out of the way so you can kind of see what I'm doing here. Oh, you stupid software, come on. Basically, I got to move that to another screen that you're not going to be able to see. But maybe I can, there we go. I can do that. Okay, so looking at the very first image, what do you see? It looks like we're looking through a possible tree branch here. So yeah, there is a problem with some of these frames. The very first frame right out of the box. So, that's a bad frame. I will press Control-Delete on the keyboard to flag that file for disposing of later. There it goes. So what happens when you do that, when you hit Control-Delete on any file or any bunch of files you have highlighted, is that file will be renamed by converting FIT, the extender, to BAK. So that way it doesn't really delete the file, but it does rename it so that it will no longer be recognized as a light file. And you do have the option to Control-Z to restore that if you made a mistake. So that's one of the ways you get rid of files. So let's look at the next one. And the next one looks okay. So I'm going to go through these one at a time. You do that by holding down the Control key. And it looks like there's either a cloud or some kind of a light that came on, maybe, possibly, while these were being taken. I'm going to say that looks like a cloud that went by. So that's going to be that frame. Whoops. This frame, and it's going to be those three frames. So we will take those out of the stack. See what else we got here. Oh, satellite tracks. See them? Right there. Boom. 2 of them. Fuck you, Elon Musk. Damn it. Get rid of that one. And, yep, we got more. There's another one. Oh, there's some more. There's another one. Okay, the rest of them don't look real bad. There's a couple of them that look a little smeared up, but they're at least all in focus. I'm going to call that good. So what do we have? We are now down to 15 good frames out of the original. I don't know how many I started with, but maybe it was 23. So we have now culled that list down to what I would consider to be the best frames that were left from that observation. So I will keep these and at this point go to my light folder, where those files are kept. This is the F drive, astrophotography. There we go. I'm in the M48. Look at this light folder here. So as you can see, just like I said, it took some of those files I flagged as being bad and renamed them to BAK. Let me sort by type so I can get those all together. Quite a few of them. Now, a lot of folks would probably keep those files, I suppose, but I'm not going to keep them. If they're bad frame files, I do not see any need to keep those, and I'm going to get rid of them and recover that hard drive space. So I'm going to highlight all those back files and delete them. And I now have my final stack of frames. That's a very small stack, but for a star cluster, it'll do. It'll get me a picture. So let's... Okay, at this point, I could close out this software and go fire up Cyril and process that stack of lights to get my picture. But what I want to talk about here is, while I was doing this to cull my images, it occurred to me that one of the things you can do in here in this software is you can select all. You can highlight all your lights, even if you've got hundreds of them, don't matter how many. You can highlight all of your lights along with all the data that was generated off of the FITS files for each one of them. You can copy the selected rows to the clipboard. You can then take that to Excel and store that in your own FITS database. There are probably software programs out there that can do what I'm about to show you, but I chose to build this myself. So, once I realized that it would be possible to make an Excel database to store all this data, that's really what I'm going to show you now. So I've copied all these. I'm going to fire up the Excel file that I created to store all of my FITS data and show you what it looks like. So let's do that now. Where are you at, Excel? There you are. This is the all light frame database. Version 1.00. Click to proceed. And here you see the database. It opens right up on the main database page. There's some information available right off the top of the page that I put there. But I can also see a quick summary by just clicking the Total Report tab. And what it tells us is that so far I've collected 25,471 frames, which is 200 observations made over 50 nights. I have observed 98 distinct individual objects. I've used 5 different filters among all the observations, and I have observed from 3 different locations. Total observation time has been 92 hours, 47 minutes, and 12 seconds. And the average time per observation, 27 minutes, 50 seconds. There's a copy of that data down here that is a copy of this. When I add my new records, then this information should all update, and this information will stay the same, and that'll give me a method of double checking to make sure that I got my data added to the database. But here's the database that I want to add my new data to. And you can see the filters are already in place, and I can filter by object and filter by whatever. If you know how to use Excel, you know there's a lot you can do with this data once you apply all these filters. But the database is rather large, even though I'm kind of new to astrophotography. We have 25,473 rows being used. First 2 rows are for headers, so really you end up with basically 25,471 frames, or records of frames. So, one of the things that you're going to need to do if you're going to maintain a database like this is add new records as you get them. I made a bunch of new observations last night, so I need to add. the new observations to this database. And it can be done manually, which is a little time consuming, not hard, but kind of time consuming. But what I have done is gone to work to write the macros necessary to allow me to load in my new data fairly quickly. So that's done by going to this tab here called Import Records. So what I do then, I would paste my data in cell A1 and then press Control T on my keyboard to activate this code right here that I wrote, which will automatically import my data and place it into the All Light Frames database. So let's see what that looks like. With the data pasted here on the Import Records tab, I would press Control T, and I get a confirming message telling me my ASTAP data has been added to the database. Let's have a look at the Totals Report tab. And the Totals Report tab is telling me that 15 frames have been added, which is correct. So I know that the import was successful. And this is the data from before I imported. This is the data after I imported. So we have an increase in the number of frames. We have an increase of 1 for the number of observations. This is simply a way for me to double check and make sure that the data I imported was imported correctly. Number of objects increased from 97 to 98, which means that object I added was a new unique object that I'd never had before. And the times have all updated. So that tells me the import was correct. And of course I can visually confirm that by just going straight to the actual database. And just jump right down to the very bottom and see that my data has been added correctly. Now, there are some additional columns here that you can't see. They're off the screen. Let me go back to the top. Which is why that there is some processing required to add the data to the database, because what I have done is I've added some additional columns. So the columns in orange are columns that I've added to the data provided by the telescope. I've added a date and a time column. The date and time column, what that does is it takes this piece of information the telescope provides. Both the Dwarf Lab and the C-Star provide a date-time code. That's what these numbers are. These are numbers that, believe it or not, represent both a date and a time. Since I don't know how to read those directly just looking at it, I have extrapolated the date and the time off of that code that's in this column over here into these two columns, so that I know that on this, for this particular FITS frame, it was taken on the 10th of February 2024 at that time of the evening. That's the date, that's the time. I also added a column to manually type in a location, mostly because the Dwarf Lab 2 telescope I have does not provide lat longs for where the telescope was located when pictures were taken. The C-Star does. It gives you lat longs, but the Dwarf Lab doesn't. So I've added this column for me to manually type in where the telescope was located when the picture was taken. I added a temperature Fahrenheit column. The Dwarf Lab does not provide a temperature, but the C-Star does. But it provides it in Celsius, which is what this column L here. If L is blank, it means that was a Dwarf Lab observation. Let's go find a C-Star one. Here we go. So C-Star gives it to me in Celsius, and I'm an American, so I need to see it in Fahrenheit. That's what this column over here does, is convert that number into Fahrenheit. So we can see that on that particular night and time, it was 37.4 degrees internally in the telescope. I did add a lat long column also, because the C-Star does provide that data, although it does not appear in the ASTAT FITS frame analysis. So I'm currently working on a way to automatically import that over here. I'm just not done with that yet, but I'm getting there. That is what this tab is for, this hidden tab. It's a future project I'm working on to get the lat long populated in here automatically for me instead of me having to put it in manually. But I got the columns there for it. It's ready to go. I've also added a column called Session Identifier. This is the way that I use analyzing this data to determine which FITS files fit together into a single observation. And it is done by creating a session identifier, and that is how observing sessions are counted in this database. I create a specific session identifier that consists of the path that the file was located in, and added to that is the first part of the file name. The combination of the path and the first part of the file name will generate for me a specific identifier that identifies an entire session, which I can use this formula to analyze that column and count how many different sessions I have done so far. To date, 200. But that's how that's done, and that's why all these columns are here. So when I add new data to this database, the macro I've written plugs this data into this database along with the additional columns that are needed to create the final total database. I color these columns differently just so that I know those columns are columns I have added, and they're not part of the original data set that came out of ASTAP. Okay, so anyway, there you have it. That's the All Light Frames database that I've created to keep track of all my FITS frames, and I'm sure I'll be able to find a lot of good uses for this. I can already think of a few off the top of my head, but I'm sure there are many things this can be used for that I will put it to use for. Let me get back to my self so you can actually see me. Sorry about that. Yeah, so now that database has been created, I can proceed with processing the photographs that I took last night, and then a couple nights ago on the 20th. I got a bunch of sessions done too. Well, like I said, I was kind of sidetracked by getting this database project done, and it's almost complete. I still got a few things left to tidy up on it, but it's definitely in usable form right now, and I'm going to really put this thing to use here in the future. So that's it for now. As soon as I get done logging the rest of my observations from last night, I'll finally get around to processing the pictures from the night of the 20th and last night, which will be part of a new slideshow that I'll come up with in the very near future. But anyway, that's really all for now. I just wanted to show off my new Excel database that I created, and hope you've found any information in this useful. Ta-la!